Hi everyone, I'm Jared Finder. I'm in charge of the Unity SDK for Google's Project Tango. And today I'm going to talk a little bit about what Project Tango devices can do. I've got one right here. And I'll also talk about best practices and what it actually takes to build an app. So I'm just curious, before I go on, how many people here have heard of Project Tango before? Just show of hands. And how many of you have actually used a Project Tango? Less, but still a lot. Wow. It's just always awesome to see that. I'm like, wow. So anyways, for those of you who aren't familiar, Project Tango is about enabling mobile devices with some extra sensors to have this three-dimensional understanding of the world that enables mixed reality apps. So it gets a three-dimensional understanding of where it is and the world around it, allowing it to interact in a way that's outside just the two-dimensional screen. This is done via our core technologies. We have 3 core technologies we expose through the API. We have motion tracking, depth perception, and area learning. Motion tracking allows the Tango device to understand its relative three-dimensional position in the world. So as I move the device around, it knows in 3D how much it's moved in the world. And it knows its orientation too. So it's got a full 6 degrees of freedom. You can think of it like a mouse, but that has a full 3D controls. Depth perception is what allows it to understand the world around it. So it gets a point cloud and uses that to understand the three-dimensional geometry of what it can see in front of it. This enables apps to then place things and interact with the world. And finally, area learning. Area learning allows the Tango device to know about the world that it's seen and have a bit of a memory. So it can recognize things like, oh, I've been in this room before, those exit signs have a particular layout relative to the doors around them, and then it knows where it is in this room that it's been in before. And this memory is encoded into a file that then can be shared and shared with other people to allow multi-user apps so that the 2 apps can both have the same positions in the world or be talking in the same world. So these technologies all work together to enable apps on Tango devices to have this three-dimensional understanding of the world. And now I'd want to actually talk about what it really takes to write a Tango app. Tango apps are just normal Android apps, but they get to take advantage of our extra APIs to actually have this understanding. So if you're making a mixed reality app, it's all about taking virtual objects and adding them to the real world. And you want these virtual objects to act like real objects, right? You don't want them to overlap with the real world in any way. You want things to stand on top. As you move the device around, they should appear to move naturally. And how is this actually working? If you look at the real world, physics is basically doing this for us. As you move the device around, you see objects from different angles. The objects don't move, the real objects, because they're not moving. And if you think, as you move around, you're just seeing different photons that are hitting your eyes. This also enables occlusion, where objects that are behind other objects, you don't see them. Because right now, I can't see the floor directly below the podium because the podium is blocking all the photons that would bounce off the floor and reach my eyes. So physics is actually solving a lot of the problems that we'd want to solve for the real world. Yay for physics. However, if we want to place a virtual cat in the world, we have to basically solve all these problems that physics is otherwise solving for us. We can't rely on physics anymore. We need to write code. And so what you would do if it was fully virtual is you would place a virtual 3D camera somewhere, and you would place the 3D cat somewhere. They'd both have positions and orientations in some world frame that you'd arbitrarily choose. So you could say oh, I'm going to choose this position as the world, and I'll say that my camera starts at the origin, and a cat is 2 meters in front of it. Then, as I move the 3D camera around in the world, giving it new positions and new orientations, I would see the cat from different angles. This, if you've done any 3D rendering, should sound super familiar. This is just standard 3D rendering where you've positioned objects in 3D. So now if you want to do this for Tango, you get to use our motion tracking APIs to actually position the camera. So as the Tango device moves, you're basically moving the 3D camera around and positioning it where the device is. To make this concrete, you want to call this specific code. So our core API for motion tracking is a function in C++ called getPoseAtTime. What that does is you say, what do you want to know the pose or the position and orientation of? In what frame do you want it? And at what time? And so as I move the device around, I'm going to, every frame when rendering, say, I want the position of the device. I want it relative to that world frame. So this is something Tango calls start of service, which is just where the device was when you first started. And I want it now. So you can see in the code here that I'm passing in for base, the start of service. That's the world frame. For target, the device, that's the thing I want to know about. And the time is now. When we do this, now as I move the device around, I'm going to get different angles of the cat. However, we want a little more. We want this cat to actually feel like it has a presence in the world. And so to do that, there are all these different places that it could be. It could be on top of the table. It could be on top of cushions. And here, Tango's depth sensing API comes in handy. Now, depth sensing provides the app just point cloud points. But we know that what people really want to know about is where's the specific position you've tapped, and what's the shape roughly there. So we also provide an SDK, in our SDK, a function that allows you to ask, what's the plane at this point? What's the overall shape right around here? And so you could see in different places, you have different planes at different positions. Now, a little detail that goes on here that if you don't think about it at first, actually you might not even realize, is that the Tango device is moving around as you are capturing all this data. And so the position of the camera image and the position of the point clouds where the device was is actually different. And so you need to store the relative pose of the point clouds relative to the camera position. And so luckily, because this is so common, we provide a way to do this for you. You can say here that you get the camera position at the camera time, and you want to know where the point clouds are relative to that at the point clouds time. And it gives you a pose that you can then go and ask, what are the plane for this position, for this specific camera image and point cloud pair at a specific point. This function will return a position and a normal. So given this, now that we have this, we can place the cat at that position, and you'll actually get to see that the cat is standing on top of the world. Let me show you how this looks. So can we switch to the Tango device? So this is a standard Android app. It is written in Unity because we find that many people want to use C and Java and Unity. And you can see that right here, there's already a cat right there on the floor. But I can tell it to go to different points. If I tell it to go up here, it jumps up to the table. And you can see it's standing right there. Oh, it fell off. So it can travel around, and it knows the shape of the world, even as I move around it. All the processing is done locally on the device. And it's just standard Android, so you're used to the usual things that you get. However, you may have noticed a problem. You can see it right here. The cat's technically on the floor, but if I move on back, the podium should be blocking it. And so to do that correctly, this is that occlusion. You need to do a little bit more processing. Oh, I already did that. So Tango can use these point clouds to build rough 3D meshes that approximate the geometry. These are not fully accurate. They're not at the atomic level. Oh, can we switch back to the Mac? Ah, thank you. So these meshes are not fully accurate. They're rough approximations of the world, but they can be captured in real time. Building these meshes is actually pretty hard, but we provide an API where you just give it a point cloud, and it will give you a mesh that's in a suitable format for rendering. These meshes can then be used to fill out a depth buffer, which 3D rendering uses to do occlusion. Now remember that this mesh is only approximate. So you can't get, like, what you'd need is atomic, or I like to say photon level accuracy to actually simulate the full photons being blocked. So you need to do a little bit of a workaround. Let me show you what this looks like. Could you switch back to the Tango? So here I've got the same app, but I'm going to build a mesh of the world. And so you can see I'm getting a mesh all in real time right now. And when I'm satisfied, I can say use mesh, and now that mesh will be used for occlusion. The cat's there, but if I walk back, let me actually get it a little closer. If I go back, you can see it's starting to get occluded as I bend down. And so you realize what's going on visually, even though it's not perfectly occluded. We're switching from drawing the real cat to drawing the outline of a cat. And your brain, I find, can understand, oh, now the cat's there. Now the cat's being blocked. And this is done because we know that the mesh is only an approximation. So we are blending between fully occluded and fully visible. Can I just go to my last slide then? OK. So can we go back to the Mac? Oh. So there's many more things to talk about here at Tango, but I've been informed that I'm out of time. So I just want to say like one or two more things. You have to realize that while we are continually trying to improve our algorithms, but there is still a lot that can be done. And we're never going to quite be perfect. So part of this is on you, the application developer, to be able to communicate well via your art, via your features, what you actually end up wanting to do. And one thing I just want to say, it's important to remember that every single feature you use consumes extra CPU, generates extra heat. And so if you can do without occlusion, and we find many apps can, you can create a compelling experience and have more stuff available for you. The last thing, and then I know, because I know you're eager to have me go, we're just at the beginning of things.
I'm not.
We're just at the beginning of things here, and very soon we're going to be excited to have the first consumer Project Tango device, which will be launching by Lenovo later this year. And that will be a standard device. I feel there's one guy over there who's super eager to ask a question. I just want to say thank you for this.